Travelling to the stars. The ambition of starflight has been with us for arguably thousands of years. I'm quite sure that when prehistoric man was sitting in its jungles and caves, that it was also looking up at the stars, wondering what they were, whether those were distant campfires or some other construction of which their imaginations could not conceive. And they wondered whether they could go there. Today, we can consider this problem from a different context, because we have actually been into space. We have a different understanding for the nature of human beings in the cosmos. We know that the Earth is 4.5 billion years old, that the Sun is 5 billion years old, that we are rotating in a galaxy at 220 kilometers per second, taking around 200 million years to rotate around the galaxy, and that our galaxy, which may have 100 to 400 billion stars in it, is merely one of billions of galaxies that exist in this enormous universe, which is 13.8 billion years old. To attain that information, to have learnt that and to have understood that about our universe, has taken many centuries. Centuries of developments in science, in understanding, in philosophy, going back to the Greeks and even before the Greeks, with, say, the ancient Sumerians who were looking at numbers and thinking about our place in the solar system. So when we consider this, and we consider the context by which we can think about the universe, we're in a privileged position to be able to speculate about the future, what you might call strategic foresight. And of course, in the future, people who speculate should be better at it than we are. So, given our standpoint and our technological maturity, does it look like human beings will ever travel to the stars and beyond? Well, the nearest stars are 4.3 light years away. That is, it takes light 4.5 years to travel that distance. Light, of course, being the fastest thing in the universe at 300,000 kilometers per second. We would travel at a mere fraction of that speed. Our best estimates for energetic propulsion systems, say using fusion, maybe moving at 10% the speed of light. You're only moving at 30,000 kilometers per second, which is really quite small. If you consider the size of the galaxy is 100,000 light years across. And so even if you could travel at the speed of light, it would take that long to traverse it, 100,000 years. Of course, if you were traveling at 10% the speed of light, as with those energetic fusion reaction systems, then it would take 1 million years, etc., etc. Now, many authors have argued that we can consider human beings or any other intelligent species expanding throughout the galaxy over millions of years as a form of interstellar diffusion. But actually, I'm not sure that this works. Isaac Asimov, of course, in his beautiful Foundation series, talked about the rise and falls of civilizations. Isaac Asimov had read Gibbon's The Rise and Fall of the Roman Empire, and had also considered particle dynamics, what happens with particles when they are energized, and how we'd evaluate them from a statistical point of view. And this was the basis of the mathematics that was used in Harry Seldon's kind of modeling of the rise and fall of civilizations in a galaxy. But in reality, this doesn't really work, because particles, of course, are much more simpler than human beings or any other complex life forms. Particles are only defined by a few properties, such as charge, mass, spin, whereas human beings are defined by so many variables. And of course, our personalities are incredibly complicated and very different from person to person. So when we consider this, it seems that the idea that human beings are going to travel across the galaxy over any meaningful time period starts to become implausible. Now, it is possible that we could find what's called a physics loophole, going faster than the speed of light, a mythical warp drive or a wormhole. But of course, there's no evidence that we could build such a technology, and there's no evidence that anybody else has, although it makes for great science fiction. So from our perspective today, we really are left to the slow mode transport mechanisms. And given that, it's not really conceivable that human beings can travel, say, more than tens of light years distance. And so really we could only access a fraction of the distance of our galaxy. Now you could of course go to world ship arguments. So a world ship is an enormous vessel that's traveling at, say, 1 to 3% of the speed of light. And it's taken thousands of years to travel between star systems. And so human beings will come and go with different generations. So lots of babies are being born and retrained to drive the ship, etc. That is certainly one way that the universe could be colonized. But if you look at the history of human civilization and how our own civilizations have come and gone, it's difficult to conceive that a world ship with an initial social, cultural system, and legal system, an economic system, which starts out on its journey, that itself does not undergo some revisions along the way. And those revisions themselves have the potential to either improve the potential for survival or to put it at risk. Of course, if it's human beings we're talking about, who are very creative and imaginative and curious, and we want to explore and do other things. So if, for example, the world ship was traveling to a particular destination, but along the way they happen to pass something of great interest, you might have a revolt on the ship because half the crew want to stop and explore this other world instead. So there's lots of potential instability mechanisms on a world ship, which I worry about. So traveling across the entire galaxy seems quite difficult, I would argue. And indeed, even if you could go at relativistic speeds, such as approaching the speed of light, you start to be hit with the time dilation effect of Einstein's special relativity, which means that your ship time may be fast, but for everyone else back home, for example, time is going by, and it's just, if you were to return home, say, tens of years later, it may be that thousands or even millions of years have passed on Earth based on the speed that you were traveling at. So given this, it seems difficult to conceive that human beings can travel the entire galaxy in this way. Now, it is possible, of course, that human beings could find a way to live for a much longer lifespan than we do currently. Currently, we live to 70, 80, 90 years old, depending on which part of the world we're living and its economic, environmental conditions. With the advances in medical science, we can conceive that all organs could be replaced, all bones, all flesh structure. The last remaining complexity for us is, of course, brain, because we don't understand the nature of consciousness. But it seems that, in principle, we could in the future get to a point where we could at least map across the characteristics and properties that constitute the brain and its mind without necessarily understanding what it is, such that we could reproduce it. So the idea that we could, for example, upload human beings into a new body sounds science fiction, but I think it's not unreasonable to extrapolate current developments in science, and in medical science in particular, to conclude that that is at least possible in the future. So in the future, human beings could live for much longer lifespans. But then, of course, it's a question of would we want to? I think most of us would argue, again, depending on our socio-economic conditions, that we'd like to live a bit longer than we do. There's so much to explore in this world after all, from science to art to poetry to music, to exploring the world and everything that lays outside of it. But would we want, for example, to live for 1,000 years? How would we deal with that? Would we become bored? Would we become melancholy or stagnatory? Would we actually desire death? But assuming that we could live for such long periods, this would certainly help us in terms of traveling between the stars. But maybe there's a limit to that too, because the size of the universe is so big that it dwarfs even those numbers. Of course, I'm talking here about flesh and bones, but there's the other side of space exploration, which is the robotic probes. Indeed, human beings have only been as far as the moon, but we have sent robotic spacecraft to the edge of our solar system and beyond. I'm talking, of course, about the Voyager probes, which were launched in 1977. Both Voyager 1 and Voyager 2 are still transmitting today, and they are considered to be outside of our known solar system, that is, outside the termination sock and the solar heliosphere. So in the future, we will probably send vessels much further than 100, 150 AU to perhaps 1,000 AU or even 10,000 AU, and eventually to interstellar distances. It's certainly easier to send robotic probes than humans. You don't have to worry about so much mass, you haven't got to feed them. You don't need lots of water. They don't need space to play and have fun. And of course, they can undertake high G accelerations. This is particularly the case, for example, for laser beaming systems. For a laser beaming system, you could propel something at, say, 20% the speed of light, which is 60,000 kilometers per second. And it would arrive at the nearest stars in only 2 decades. But that would require accelerations of something like 5 to 10,000 G, depending on the mission architecture, which human beings could not withstand. The problem with that technology is it requires enormous amounts of power, gigawatt, in fact. And if you want to send anything bigger than gram scale, up to kilograms and even bigger tons, you quickly move into the terawatt power capacity and beyond. And this is one of the problems with exploring space, whether it's trying to get into low Earth orbit or trying to get out of the solar system to the nearest stars. Mass is everything, and mass requires energy to push it to achieve that velocity. Human beings, of course, if you want to send them to the stars, they require lots of massive structure. As I mentioned, water, food, and all of the other things that human beings have with them. Now, I mentioned faster than light travel and wormholes, and I mentioned that there's no evidence that they exist, although we should always be optimistic and never say anything is impossible. But we have reason for optimism a little bit, which is that although the science has achieved so much in our understanding of the universe, there's also a lot we don't understand. Albert Einstein left us his legacy of special general theory of relativity, and when he died, he was still working on a grand unified theory. That is, trying to unite all of the forces of physics together into a cohesive synthesis. He did not achieve that, but there are, of course, groups out there today still attempting that goal. The string theory community, the loop quantum gravity community. In particular, the problem is gravity. Trying to unify gravity with the strong and weak nuclear force and electromagnetism. And of course now we have the Higgs force. There's also the enigmas of dark matter and dark energy. We don't know what those are. Dark matter, of course, first came to our attention from rotation curves of galaxies, showing that the amount of mass in a galaxy appears to be different to what we could actually see, hence the name dark matter. Dark energy has come to our attention because the universe is not only continuing to expand since the Big Bang, but the last few billion years, it appears to be accelerating in its expansion. That is very interesting, and nobody understands why. There is the fine-tuning of all the particles, the mass and charge of the protons and electrons and so forth. We don't understand why they have such fine-tuning. So all of this gives us reason to think that there is still lots of physics to be uncovered by our scientific inquiry. And so it's possible in the future we could invent machines that could indeed take us around the galaxy. But I'm not so sure. Having said I was optimistic, I think about the size of the universe, and I think about how many galaxies that are out there, many of which we can see through our home garden telescopes. And yet they are so far away. Even traveling at the speed of light, it takes so long to get to some of these objects. Well, I call them objects because they're gravitationally bound, but of course really they're quite diffuse, and the stars within them are nowhere near each other, although they do feel each other's influence gravitationally. So this brings me to another question, which is, we've got this enormous universe, 13.8 billion years old, and we have this desire to explore it through the starship, to travel to other stars, to find other planets and perhaps meet alien life forms. But let's say in the centuries coming up that we can explore this galaxy to some extent, whether it's 100 light years from here or 1,000 light years from here, we figure out a way to do it. That's still only a tiny fraction of the galaxy itself. And it's barely a pebble's drop in an ocean compared to the universe. So what then is the purpose of the rest of the universe? Is it there just for the perpetual astonishment of humankind to look at, so to inspire us with curiosity and amazement, so that we can indeed, with our curiosity, seek to explore and pioneer it? Or is the remaining universe forever out of our grasp and only to be looked at? Is in fact the galaxies in the wider universe the cathedrals of the sky, the museums upon which we can look but not touch? A couple of things really intrigue me about physics. The first is the fact that the universe is so big. From our perspective, it's essentially infinite. It's so big that we cannot reach the outer limits of it by any known technology that at least obeys our understandings of the laws of physics. Those methods which can are outside of our known laws of physics. The second is quantum mechanics, the uncertainty principle. When we look at an electron and we try to measure its position, for example, we can only know its position with a certain degree of uncertainty. And similarly, we can only know where it is and at what velocity it has, or what momentum it has, within a certain uncertainty. But you can't know both accurately at the same time. This is Heisenberg's uncertainty principle. If you try to measure very accurately, the very act of attempting to measure with those photons of light that you're essentially firing at the particle, for example, causes an electron to duplicate itself, and you end up with 2 electrons. It's almost as if reality is playing games with us, and it's saying, you can look, but if you look too deeply, we will create a mirage back at you, and you won't be able to see what's beyond it. And then there's the speed of light, which as far as we know is the fastest thing in the universe. It's a constant from our measurements, and we can't go faster than it according to Einstein's theories of relativity. If we try to approach it, we get a relativistic mass increase, the energy goes up, and it just becomes a problem so that we can never really get to it. So, what is the purpose of the rest of the universe? Is it a lonely void? That those cathedrals in the sky, those galaxies, don't really contain anything other than stars? And we maybe are the only life looking out of it. Or maybe there is life in the rest of the universe, but it's widely distributed and none of it is near each other. So maybe the next alien species is actually millions of light years away. When I ponder these questions, it takes me to philosophy and even metaphysics, because it's difficult to frame accurate questions with known physics that can give me sensible answers. And so I'm left to ponder what my imagination tells me. And my imagination tells me that it would be an awful waste of space to create a universe so big, so infinite, with only the life here. And this is what our estimates of intelligent life in the universe tells us, is that it should be everywhere. It should be ubiquitous in principle, because we know that there's lots of exoplanets now. We've discovered over 3,000 of them. And if there's water and there's energy sources, then why wouldn't there be life? And therefore, on some of those systems, perhaps evolved intelligent life. But I do wonder if the Star Trek idea of traveling around the universe in starships is actually a fantasy. And perhaps the best way we can travel around the universe is with the imaginations of our minds. Indeed, maybe that's all the universe is. It's the thought, the imagination of an entity which we might call a God. And that God thought of us, created us. And we are its ponderings, pondering itself, and wondering what its purpose is. It's certainly exciting to consider these ideas.